a perfect inelastic collision. Okay, this topic. So we see that two objects considering that A and B. So object A, its mass is m1. Object B, its mass is m2. So both are moving with their velocity is u1 and u2. This is for a before collision. Okay, so after collision, both are coming together, then moving with a constant velocity or same velocity. Okay, which means object A and object B. So object A and B, the masses m1 and m2 having a common velocity, that is v. Here v is what? Common velocity. So this is meaning about perfect inelastic collision. Now we have to find this formula for that velocity after collision. Okay, so both are moving is what? Considering the law of conservation of linear momentum. Then what is the momentum before the collision is what? m1 u1 plus m2 u2, that is equal to after collision. This means m1 v plus m2 into v. So here v is common taken out. So write m1 u1 plus m2 u2 is equal to v into the remaining thing is m1 plus m2. So in this equation you can find the formula for v. So v is equal to the multiple thing divide here. So you write m1 u1 plus m2 u2 by m1 plus m2. So this is the formula for finding that final velocity for a perfect inelastic collision. Okay, using this concept we can find out the loss of kinetic energy in the perfect inelastic collision. Okay, loss of kinetic energy in perfect inelastic collision. Okay, so first we will write what is the total kinetic energy collision before. Okay, total kinetic energy before collision. Okay, that is equal to, so we will write kinetic energy at initial ke suffix I is equal to half m1 u1 square plus for object b half m2 u2 square. Okay, similarly for that total kinetic energy after collision is equal to kinetic energy at final is equal to, see both are having the same velocity v, so we will write half m1 v square plus half m2 v square. So v is common means you write half into m1 plus m2 into v square because half also common. So this is a formula for the final kinetic energy. Okay, so we know that so what is the loss of kinetic energy in elastic collision means the loss of kinetic energy is nothing but del q is equal to initial energy minus final energy. So kinetic energy at initial minus kinetic energy at final. Okay, this is the formula. Then you apply here for these two, right? Del q is equal to, so this is initial minus final. So write the things half into m1 u1 square plus half into m2 u2 square is initial, then minus of the final is what? of into m1 plus m2 into v square. Okay, put the equation number 1. Then we know the formula for v is equal to what? m1 e1 plus m2 u2 by m1 plus m2. Here we have v square. Okay, so that v square is equal to, so we have to make it a square for this thing is what? Right, m1 e1 plus m2 u2 the whole square by in a denominator we have m1 plus m2 the whole square. Okay, so this is a form of a plus b the whole square means what? A square plus b square plus 2ab. Okay, so write in the right side. So write that b square a itself, b square is equal to c a square plus b square plus 2ab. So a square means we have two things, so write m1 square e1 square. Okay, so write m1 square e1 square, this is a square, plus b square means m2 square u2 square, m2 square u2 square plus 2ab. 2 into ab means what? You write m1 e1 into m2 u2 whole divided by, here also write directly as same thing, m1 plus m2 the whole square. This is the second equation. Now we have to substitute the equation 2 in 1. Here is v square, so write the entire thing here. Okay, substitute the equation 2 in the first equation. Okay, so equation first we have del q is equal to m1 e1 square by 2 plus m2 u2 square by 2 minus 1 by 2 into m1 plus m2 into v square. So we find the last thing is v square is equal to what? That is the m1 square u1 square plus m2 square u2 square plus 2 m1 e1 into m2 u2 whole divided by m1 plus m2 the whole square, then close the bracket. Clear? So here we have cancelled these two things. See here square terms, here one term, so cancel. Okay, so remaining thing we will write m1 e1 square by 2 plus m2 u2 square by 2. Okay, see 2 multiple here, so write the entire thing and also put the minus into bracket. So when the minus into bracket means minus into plus minus, so we'll write m1 square u1 square minus into plus minus, write m2 square u2 square minus into plus minus, you write 2, write the m1 m2 single, so write m1 into m2 and u1 into u2, then whole divided by 2 into m1 plus m2. Okay, next we have to do that LCM for the, we have three things. Okay, so the multiple of the this thing here, so write for the LCM here 2 here 2 into m1 m2, so LCM is what? 2 into m1 plus m2, so 2 here, so we have to multiply by m1 m2 in a numerator, so write m1 plus m2 into what? m1 e1 square plus, similarly we also 2 in a denominator, so you have to multiply by m1 into m2 for make it this thing, so you have to multiply by the m1 m2 in a numerator, same like this, so m1 plus m2 into m2 into u2 square. Then minus of the all the three things again repeat. So write m1 square u1 square minus m2 square u2 square minus 2m1 m2 into u1 into u2. Okay, now we have the things. So we have to multiply the separately m1 into the things and m2. Okay, like this. First writing multiple of m1 into this thing, second by m2. Same here also, first m1 then m2. So we'll get m1 into m1 become m1 square. Okay, and then what, u1 square plus m2 into m1. So we'll write m1 into m2 into u1 square. Okay, plus here m1 into m2 u2 square. So write m1 into m2 into u2 square plus m2 into m2 square. So write m2 square and what, u2 square. Then remaining things we have m1 square u1 square, then minus of m2 square u2 square minus 2 m1 m2 into u1 into u2. Okay, then whole divided by 2 into m1 plus m2. Next, for the cancellation we have c plus m1 square u1 square minus m1 square u1 square. So the plus minus are cancelled. Then m2 square u2 square plus is minus, so this term also cancel. Okay, so remaining we have m1 m2 into u1 square plus m1 m2 into u2 square minus 2 m1 m2 into u1 u2 divided by 2 into m1 plus m2. We have 3 in a numerator. See, m1 m2 is common, so take a note. So write m1 m2 is common divided by, so you write this separately, 2 into m1 plus m2. So what are the remaining things you write? See, m1 m2 is common means we have u1 square. Okay, so write u1 square plus is u2 square minus, except m1 m2 we have 2 into u1 into u2. Okay, there is a del q. See, this form is what, u1 square minus u2 square minus 2 u1 u2. It become has a u1 minus u to the whole square. For expansion we get the same thing. See, u1 square plus u2 square minus 2 u1 u2. This form of a must be the whole square. Okay, so we will write this thing, del q is equal to, see there is no means put off here, so write 1 by 2 into, we have what, m1 into m2. So m1 into m2 by, near m2 we have 2 into m1 m2. So 2 into m1 plus m2 close the bracket. So we will write this entire thing as a u1 minus u2 square. So we will write u1 minus u to the whole square. So this is the final formula for that what, finding the loss of kinetic energy in a perfect inelastic collision. So all the steps are not in your textbook. Okay, so you have to remember the entire steps, then getting the answer for this thing. Okay, del q is equal to 1 by 2 into m1 m2 by 2 into m1 m2 into u1 minus u to the whole square. Okay.